video we're going to be looking at how to factorise, and this is going to be for the foundation and the higher tier up to a grade 5. So anything that's going to be exclusively on the higher tier I will cover in a separate video. So factorising on the foundation tier and the high tier, you're going to be expected to factorise expressions into a single bracket and also to be able to factorise quadratic expressions into double brackets, but this is exclusively for expressions that don't have a coefficient before the x squared. So you won't see things like 2x squared, 3x squared, those things will only be on the higher tier. The examples that we're going to look at are going to increase in difficulty, so we're going to start with some single brackets and then work through single brackets with indices, and then we're going to finish on some double bracket expressions that we'll need to factorise. The word factorise means to take out common factors. It comes from the word factor, and we should know that factors are numbers that can be divided into other numbers and not leave a remainder, so they are integer factors. So when we're wanting to factorise expressions, sometimes we're going to see numbers that we can take out as factors and also algebraic terms, so x, y, a, b, whatever it might be. What I would suggest you do with a question like this, where you see numbers and letters, is separate them. So deal with your numbers first. So what you want to do is you want to find the highest common factor of 5 and 15. So you can write down your factors of 5 and your factors of 15 if you want to, and see which is the highest factor on both lists. Some of us might be able to spot what that factor is straight away, which is going to be 5. So I'm going to take 5 outside my brackets as my highest common factor. If you don't take out the highest common factor, what you will find is when you have your bracket left, you will still have common factors inside, and that's not been fully factorised. A lot of exam questions now will say factorise fully. That means that you need to take out the highest common factor. You will get some marks if you factorised correctly, if you've not chosen out the highest common factor, but we want to try and do that if we can. So once we've dealt with our numbers, we're then going to look at our algebraic terms. So we've got x and y over here, and then y over here. So as you can see, both of them have a factor of y, so I can take that outside of the brackets as well. Then I'm going to open up my brackets, and I need to do, how do I get from 5y to 5xy? So essentially what you're doing is 5xy divided by 5y. So 5 divided by 5 is going to leave me with 1. Y divided by y is going to cancel out as well. So the only term that I'm left with is x. And then on this side, how do I get from 5y to 15y? And again, you can see it as doing 15y divided by 5y. How to get from 5 to 15 is 3. And then I can close my brackets. What we can also do to check that our answer is correct is expand our brackets, and we should end up with our original expression. If we don't, we've made a mistake. There are some videos on expanding brackets if you're not sure how to do this. So here is our next example. So factorise 3x squared, add 9x, and we're going to do the same method as we did before. So 3 and 9, what's the highest common factor of 3 and 9? That's going to be 3. So I'm going to take 3 outside my brackets, and then this time I've got an indice. So x squared means x multiplied by x, and 9x is 9 multiplied by x. You can write this if you want to. So write out all of your terms multiplied together, because sometimes it's easier to spot the common factors. So both of the terms have an x in, so I can take that outside my brackets as a common factor as well. And then same method, 3x squared divided by 3x is going to leave us with x. Also, you can view it as what do I multiply 3x by to get 3x squared. There's multiple ways of viewing it. You've got to find which method works for you. And then 9x divided by 3x, because that's the common factor we've taken out, which again is going to leave us with 3, same as the question before. So 3x, and then in the brackets x plus 3. So in our next example, again we'll be asked to factorise, but this one we have got 3 separate terms in our expression. So we've got 6x cubed, 4xy, and then 8x squared. The method we're going to do is exactly the same, but this time when we take out our common factor, it's got to apply to all 3 terms, not just 2 of them. So we're going to start with our numbers. So what's the highest common factor of 6, 4, and 8? Which is going to be 2. So if I take 2 outside my brackets, and then x cubed is x multiplied by x, xy is x multiplied by y, and then x squared is x multiplied by x. So when we take our algebraic factors, all of the terms have to have the common factor in. So although this has got x cubed and this has got x squared in, this one only has 1 power of x. So I can only remove 1 power of x, take that out as a factor from all of the terms, because they all have to contain the same factor. So x is going to go outside my brackets. Then I'm going to see how I get from 2x to 6x squared. So 2 multiplied by 3 is 6. So 3 is going to go first. To get from x to x cubed, I will multiply by x squared. And then to get from 2 to 4, I'm going to multiply by 2, but then I'll need to get from x to xy, so I need to multiply that by y as well. And then to get from 2x to 8x squared, 2 multiplied by 4 is 8, and then to get from x to x squared, I multiply by x as well. The earlier examples that I was talking about is when you look in this bracket here when you factorise and you want to check that there's no common factor. So although 2 and 4, you can divide both of those by 2, you can't divide 3 by 2. So I know that when I look inside my brackets, there are no more common factors here, so I know that I've factorised it fully. So in these examples, we've got a quadratic expression, and because this is in the form ax squared plus bx plus c, we should be thinking that we need to put this into double brackets. The quadratic expression that we looked at earlier, the 3x squared plus 9x, is not in the same format as this. So that's why that was a single bracket and this one is a double bracket. So I'm just going to open up my double brackets, and we're looking for two numbers that add to make 7 and multiply to make 12, and it's got to be the same two numbers. So I start off by writing my factors of whatever number is on the end, so your constant term. So 1 multiplied by 12, 2 multiplied by 6, and 3 multiplied by 4, because there's less numbers that are factors of 12 that add to make 7. And once you've wrote your factor pairs, you're looking for the pair of numbers that add to make 7, which in this case is going to be 3 and 4. So you're going to have x plus 3 and then x plus 4. It doesn't matter what order these numbers are in, as long as the number is correct and the sign that goes with it as well. So in this example, we've got ax squared and then a bx and then a c on the end. It doesn't matter that that's a minus, it's still the same format. So again, we know it's going to be a double bracket question. The difference between this one and the one that we've just done is that obviously this is a minus number here, and that is important when we think about the factor pairs that we need to put in our brackets. So we're still looking for two numbers that add to make -9 or sum to make -9, and then multiply to give us 14. So again, I'm going to write out my factors of 14 first because there's less of those. So 1 multiplied by 14 and 2 multiplied by 7. Now, we want to make -9, so positive 2 multiplied by positive 7 gives us positive 14, but obviously they don't add to give us -9, they add to give us positive 9. But what you've got to remember with these ones is any two numbers that are either both positive or both negative, when you multiply them together, your answer is going to be positive. So if I was to take -2 multiplied by -7, that is still going to give me an answer of positive 14. However, -2 add -7 is going to give me -9. So those are the factor pairs that I want. So in my brackets, I'm going to have x minus 2 and x minus 7. So when you're doing some of these, you do need to take into consideration your negative number rules as well. So this example, again, is slightly different from the last one, because although we've still got a negative number here, this number on the end is also negative. So it's in the form ax squared, bx and c. So again, we know it's going to be a double bracket, and we know we're looking for two numbers that sum to make 9 minus 6 and multiply to make -27. So our factors of 27 are 1 and 27 and 3 and 9. This time, because this number on the end is negative, to multiply two numbers together that give you a negative answer, your sign must be different. So one's got to be positive and one's got to be negative. And you do have to think carefully about which one you choose to make positive and which one you choose to make negative, because it needs to sum to make -6. So the factor pair we're going to use is going to be 3 and 9, because they can make 6. So if you do 9 minus 3, that's going to give you 6. But we want -6. So some of these questions you need to maybe do a little bit of trial and error. Some of you might be able to spot the answer straight away. But if I do 9 subtract 3, that's going to give me positive 6. I don't want that. So if I do -9 add 3, that's going to give me -6, which is the answer that I do want. So x minus 9 and then x plus 3. So in this last example, this is a type of factorising that a lot of people forget about, but it has been coming up quite frequently on exam papers. And once you've figured out the trick, it is quite an easy one to be able to factorise. This one makes a little bit more sense when you expand the brackets, because you can kind of see how it ends up like this. But this is what we call a difference of two squares. So when we get our factorised form, when we expand them out, the constant term, so if we go back to this example, this bit in the middle, the constant term disappears because you've got one positive and one negative. They will cancel each other out to give us 0. But we're left with x squared. So to get x squared, you need to do x and x. They will multiply to give you x squared. To get -49, If we think of two numbers that multiply together to give us 49, that's going to be our square, where the difference of two squares come from. That's going to be 7, because the square root of 49 is 7. But to get negative 49, they obviously need to be different signs. So you're going to have x plus 7 and then x minus 7. So if ever you see an x squared, a minus sign, and then a square number, it's a difference of two squares example. So it will always be x and x, or whatever letter it might be, and then the square root of your numerical term as well.